So we're gonna go ahead and get started. Give me 1 second. I'm gonna start the recording. Cool. So hi everyone, thank you so much for joining in today, and I hope you're doing well. My name is Ann Lin, and I'm the marketing manager at Nebulaworks. And if you're hearing about us for the first time, we are a global system integrator and consultancy, and our expertise really lies in helping IT organizations move the needle on critical projects by adopting a cloud-native strategy. And that is the topic of today's discussion. We're very excited to kick off the webinar with HashiCorp. Next slide, please. So speaking today is Jake Lundberg, Regional Solutions Engineer at HashiCorp, and Anthony Ramirez, our Director of Consulting at Nebulaworks. Now, before we get started, just a few housekeeping items. If you have any questions during the webinar, feel free to utilize the Q&A chat, and folks from our team will try to answer the questions during the session. At the end of the webinar, we'll also be holding a Q&A and assign the remaining questions to Jake and Anthony. So without further ado, I'd like to pass it over to our first presenter, Jake.
Hi, everybody. Thanks for coming out. We'll be talking about HashiCorp and unlocking the cloud operating model. But before I begin, a little bit of a history lesson. So if you put in the chat, does anybody know what this tall black building is? Let's see. I'll give you a second. All right. Yeah, Scott, he jumped somewhere in New York, the Sears Tower, right? So if you were like Scott, you probably said Sears Tower, but you're right. You've been right up until 2009, in which it was renamed as the Willis Tower. And that mighty retail giant that recovered such a tower and its name is almost completely gone. This story, however, is not a story of failure, but rather one of success. And that success is really related to Sears' transition to an innovative system of engagement, and they were so critical for its eventual dominance in American retail. Okay, Sears was started in 1886 by Richard Sears as a watch business when he bought some excess and unwanted watch inventory and sold them to railroad employees. He sold that business for a hefty sum, but later started another mail-order business selling watches as well. And this is Sears's first innovation with a system of engagement. At the time, farmers in rural towns were at the mercy of local shopkeepers who would change prices for them based on whichever criteria they wanted, and often charging more for people of color. Sears sold goods by mail to anyone at fixed prices, a very favorable system of engagement for rapid growth at the time. In 1895, the Sears catalog was 532 pages and sold everything from sewing machines to automobiles to even houses. And just so you know, I once made the mistake of thinking Craftsman houses were once sold by Sears under the Craftsman name, and that's not true. It was actually a house designator was due to architecture following the arts and crafts movement that came out of the British Isles in the mid to late 19th century. That was my daughter Kitsune. She likes to be part of my webinars from time to time. So Sears Roebuck went public in 1906 and was the first major retail IPO and the first retail business that was underwritten by Goldman Sachs. As the Industrial Revolution raged on, rural folks migrated to cities, which put pressure on the mail order business, and Sears eventually opened retail stores, but again, bucked the trend of traditional retailers at the time by opening in lower middle class and working class neighborhoods far away from the downtown shopping districts in Chicago. This was the second evolution of Sears' system of engagement and helped cement Sears as a top retailer for the next 50 years, eventually leading to the building of the Sears Tower. Hi, I'm Jake Lundberg. The title might sound weird because I'm a regional manager, but I ran production HashiCorp assets at my last job, and it's one of the main reasons that I came here to work for HashiCorp and all these wonderful products that we create. So these are some questions that we typically ask our customers. Are you struggling with any of these kind of questions? Are you trying to move to the public cloud? Are you trying to optimize strategies for that? Are you replatforming your apps maybe from these monoliths to microservices? Are you just trying to, in general, modernize your current infrastructure? And these are the type of questions and quite a bit more that HashiCorp is here to engage with. So HashiCorp really is here to sort of enable four main verbs within your environments, and that's really the concepts of provisioning, securing, connecting, and running the applications and the infrastructure that support them. And we call this the cloud operating model. And so the products that we deliver are on the right-hand side. The top two, Vagrant and Packer, are open source only products. And then Terraform, Vault, Consul, and Nomad are both open source, and there are enterprise versions of our products. As a company, we were founded in 2012. This slide is actually out of date because we now have over 1,000 employees, and we've raised $340 million in funding up until now. We enjoy 700 enterprise customers. We have 7 out of 10 of the Fortune 10 and 8 of 10 of the top global financial companies. If you have a very serious business, it's a highly likelihood that HashiCorp is somewhere running the infrastructure. And any of the products that you consume on a day-to-day basis, again, very highly likely that HashiCorp software is somewhere in the middle of it, especially if those folks use cloud resources. So the sort of the basis of the cloud operating model is that we've seen a fundamental shift from using traditional data centers, which we consider to be kind of largely static infrastructure, to what has become what we consider to be the modern data center. And usually speaking, this is a combination of a couple things. Most large organizations that have been in those traditional data centers, they probably still keep their systems of record inside of their private clouds or inside the private data centers. But that system engagement, the difference maker, like we talked about with Sears, are largely moving into the public cloud. And they do that because of the ability to have very agile and largely scalable systems in which to engage with their customers. Some of the enterprise customers that we deal with, these are sort of their concerns. We talked about the fact that all of our products are open source by nature, but if you're looking and trying to understand whether or not the enterprise versions of products are good for you, these are typically the reasons that people come to us for those. So you're trying to optimize cloud costs, you're really concerned about cloud security, and probably most importantly is the fact that you have some kind of governance concerns that you have. Again, very large companies, especially public companies, have a lot of these concerns, or any companies that are migrating to those spheres. So when we split the process of moving to the cloud up into those 4 verbs, the shift that we see between sort of traditional data center operations to the cloud has fundamental problems, right? So first of all, we've moved from dedicated sort of homogeneous servers, usually like Dell or HP, or sort of pick your vendor of choice, to largely capacity on demand and heterogeneous environments. You actually probably don't even know the hardware that your systems are running on. At the provisioning layer. At the security layer, we've moved from a very high trust IP based situation where you have these sort of castle and moat setups to now we've moved into clouds. We have a very low trust or identity based way of doing security, because again, we don't own the networks. We don't own a lot of the software or the hardware that's there. So we have to come up with new paradigms of securing those resources. At the connection layer, again, very similar type of an idea is that we were networking our systems based off of very static based systems. Now we're moving to more service-based or dynamic IPs because our systems are ephemeral. And the reason for that is because of the next layer. It's really this run development layer where, again, we had dedicated infrastructure for running our applications. I used to work in advertising and we had ad servers, like racks and racks of ad servers, and each one of those servers only worked against one ad server. So now we're scheduling things across a fleet of servers, right? So we want to optimize the usage of our environments by being able to dynamically allocate applications across a fleet environment. So when we look at the ecosphere of what the next sort of challenges is like now each of the clouds or any of the private clouds have their kind of own way of doing things. And so when you look at the traditional data center, VMware was really sort of the major player in the virtualization space. But when we move into the cloud, in order to provision those cloud resources, maybe you're using Terraform Locate, maybe you're still using some of the vCenter or VRA or something along those lines. But when you go into the clouds, you're using CloudFormation or Azure Resource Manager, or Cloud Deployment Manager, add on the tools for Alibaba and Huawei and Tencent and any of the European cloud vendors. And you start to see that you're now having this explosion in the type of tools that you have to manage if you want to go and be multi-cloud especially. And that's just at the provisioning layer. As you start raising yourself up the stack into the security layer, now you have a large difference in the way things are provisioned there as well. So maybe you're using IAM or AD technologies, maybe using some custom security software in the security layer. And then it just, problem sort of compounds as we get up and up the stack. And realize is that this is just 3 clouds. If you start to add in more cloud vendors, if you're adding like DigitalOcean or Rackspace or something along those lines, all those folks have their own tool sets. And so the burden on your administrators and the burden on your developers to operate in these environments is very large. And this is really where HashiCorp comes into the mix. Our aim is to really consolidate and really sort of make this process a lot easier. So at the provisioning layer, Terraform has the ability Terraform has many different provisioners that are they're sort of like plugins for the various clouds. And so you can use one common language in order to provision things across the cloud. Obviously, the resource definitions are different, but the process and the sort of workflow in which you use to provision things in the cloud is very much the same. And as you start going up the stack, all of our tool sets map into these areas. And so Vault is a security layer that's common across all the clouds. It's very API driven and extremely scalable. So you can have Vault across any of the clouds that you have, and you can have these communicate with each other. At the connecting layer, this is probably one of the more exciting technologies as Consul has gone from mostly a service discovery and KV engine to now include service mesh capabilities about being able to mesh in your services across clouds. Not only are you meshing things across clouds, but you're also meshing things across technologies. Whereas some of the other technologies in the service mesh space are very specific to the run platforms that they're trying to solve problems for. Consul allows you to bridge the gap across any of those technologies. And last but certainly not least is Nomad. And while a lot of folks are very focused on the Kubernetes ecosystem, we see a lot of very high scale deployment cases with folks like Roblox or Cloudflare for that matter, that are using Nomad for doing deployments because of the simple mental model and the fact that it's extremely scalable as well. Okay, just to kind of some of the other sort of layers that we have inside of here. So HashiCorp really addresses the problems at the first 4 layers, and those are very largely infrastructure based, and plus a little bit of a nod into the runtime environment. There are some other technologies that are out there, such as messaging platforms and databases. And the fundamental reason that I add this in here is just to show that the shift from doing sort of traditional operations into these new operations, HashiCorp is the leader, and at least 3 of the networking spaces and is gaining a lot of traction inside of the orchestration and runtime environments as well. So sort of just, this is just a show of what it's like of having sort of another set of problems that we're looking at is, again, from the bottom, is that a lot of our customers are having issues with governance and compliance. And when they use Terraform, and they use Terraform as a consolidated system, either both the open source and then especially into the enterprise side, is that we're able to do quite a bit of workload enablement, rapid iteration, and governance in terms of doing infrastructure deployments. I have so many customers that are worried about secret sprawl or fear of a breach. Vault helps to reduce that. I have one customer that had over 140,000 secrets in version control. When they implemented Vault, all of those problems went away, and they tightly sort of integrated their secrets management with their application platforms. On the console side, a lot of this is really related to manual processing that folks have about doing and configuring application networking stacks. And so console is dynamic by nature and highly scalable. And so we have a very scalable, dynamic way of doing service networking. And again, on the Nomad side of things, a lot of times we see that people pick Nomad because it's, again, highly scalable. All of our tools are designed for very high scale operations. But even more importantly is the easy mental model. I spent 2 years moving my last company into production with Kubernetes. And this isn't to say that there's anything inherently bad with Kubernetes, but there's a lot of cases where people have a different need. Of they have very simple scheduling needs, or they have heterogeneous needs where maybe not all their applications are in containers. And so adopting Nomad helps people shift very quickly into modern scheduling frameworks without maybe some of the lift and overhead that you might need with an application platform like Kubernetes. We don't have naming rights for this particular company, but one of our telecom customers had a 22-week process to do application delivery. Upon adapting all of our tools, they went from 22 weeks to a 5-minute delivery process for releasing their applications. GM Cruise does does thousands of configuration updates to their infrastructure per week with using Terraform. The Adobe does somewhere in the neighborhood of 800 million secure transactions per month with Vault, and we see this same pattern happen with large financial institutions who encrypt everything inside of their environments. Consul is used by Mercedes-Benz to do Kubernetes deployments. And remember, this is, Consul is workflows like technology. We have the ability to work within Kubernetes and outside of Kubernetes as well. Mercedes-Benz uses Consul within their Kubernetes environments for doing networking, or application networking. And lastly, probably one of my favorite use cases is Roblox. If anybody has kids out there, or you're just a gamer in general, you've heard of this platform. And Roblox went from a very highly manual Windows-based release for their software to an extremely fast release process using Nomad. They actually scheduled Nomad on top of Nomad, which is very interesting. And they also schedule Kubernetes on top of Nomad. And so this idea that you can have these heterogeneous, highly scalable platforms is something to be desired out there. Okay, so I think, when we talk about sort of the sort of process that we see most of our customers go through in adopting our tools, really this is kind of the journey set that we typically see. And so most folks are worried about the infrastructure itself. And so Terraform infrastructure as code. On the Vault side, really secrets management, and then Consul service discovery. And so as folks start to sort of mature their journey and they move up the stack, they start adding in some extra sort of capabilities. So compliance and governance and self-serving infrastructure on the Terraform side, that's a very regular journey. And then and encryption as a service, advanced data protection for Vault. Network middle layer automation and service mesh for Consul, network middle layer automation for folks who have existing hardware resources that they need to support. And then of course, service mesh for folks that are adopting modern application delivery systems. And then Nomad, of course, because a lot of times folks are modernizing their environments, these are the kind of challenges that they'll go to later, and really doing heterogeneous workload orchestration probably at the end of this type of thing. And so, so great. So this is really what HashiCorp is focused on, just really modernizing your application infrastructure and doing all that stuff. And so one of the main sort of issues that folks have, though, is that all this sounds good and great, but it's not necessarily a trivial thing to do. It's great to understand these concepts, but what it really takes a lot of times is to have a good partner to help you with these transitions. And so one of the things that we highly suggest within HashiCorp, especially if you don't have an internal team who is versed in doing these things, is working with a partner. And that's really why I'm excited to be here with Nebulaworks today, is because Nebulaworks has a system in which they help folks do these transitions into their sort of modern application network infrastructure. And so I'm going to hand this presentation over to Anthony, and he's going to walk you through how Nebulaworks helps drive cloud native operations. And so Anthony, just a sec, I'll stop sharing and take it away.
Great, thanks so much, Jake. So one moment, I'm just going to pull up my presenter notes. Awesome. So hello, everybody. And as Jake mentioned, I'm the Director of Consulting at Nebulaworks. And today I'm going to talk about how a team can leverage specific processes in order to help drive cloud native operations. So this presentation focuses on Terraform's role in cloud native deployments. And there are many ways to build apps and infrastructure in the cloud, but there's some best practices that I'm going to be sharing today around leveraging Terraform, source code management etiquette, and generally leveraging Agile as a way to organize work streams and initiatives. So this deck was put together for the main purpose of sharing information and knowledge with the community. There's so many different methods, as Jake mentioned. You could be leveraging CloudFormation, ARM templates, Heat. There's a lot of different methods that you could use specifically for deploying infrastructure. And sometimes leveraging certain tools with certain processes wield better results, more productive workflows. So I want to just basically distill down what a team would need in order to build a cloud native model to provision infrastructure and applications in the cloud. And another thing is that it's important to understand that the processes that we leverage, the release engineering processes, the branching strategies, are what are going to help us have functional and stable code released on some cadence. And normally you might be leveraging some branching strategy or release engineering process in order to release stable code. And today I'm going to share a little bit about what we do internally at Nebulaworks and what we suggest some teams use if they're just starting out on this journey. So before I get into the details about these things, I want to share a scenario. Oftentimes, when I'm working with clients, we're a consultancy, so oftentimes we're building platforms or systems for clients. Typically, we have an engineering team, and this is an operations team, an infrastructure team that's tasked with leveraging a new set of tools and a new set of processes. And this might be because the new set of tools are more efficient. They have benefits, like Jake was mentioning. There's a lot of benefits for leveraging these tools. You get faster deployments, you get better consolidation. Maybe the language that you leverage, the domain-specific language, is easy to use, it's simple, and it's applied to multiple platforms. There's a lot of advantages that we can glean out of the tools that we use. Or maybe an engineering manager or someone a level above you is requiring that a tool to be used. So this engineering team, with maybe minimal knowledge about how this technology actually works, not having the experience of doing deployments, are now tasked with deploying a complex distributed system in the cloud. And so the deployment here, I'll show a little bit bigger picture of this architecture diagram, but this is a build that I worked on together with a couple of other engineers. And we had to deploy a set of distributed systems leveraging Terraform in the cloud. And if you're just starting out on this type of journey, there's some things that we want to keep in mind to avoid. So first off is, if we're using a tool or trying to adopt a tool, or we purchase the tool, we want to create value with that. We want to justify the cost of purchasing it and using it. So we don't want it to become shelfware. We want to make it useful. We want to integrate it and have internal customers see it to be valuable. Another thing is, when we're building out code bases, specifically with infrastructure as code or any other new technologies, whether it's Kubernetes, which is also a declarative tool, or just general adoption or starting out MVPs or POCs with general purpose languages, we want to avoid standalone repositories. Or imagine a team that is working on building this really great project, and they don't share any of that code with the rest of the organization. So now we have siloed repositories with maybe limited transparency into how it's being built, and generally not getting the adoption and traction that we need. Another thing is having an unorganized code base, or in some cases, think of it as having branches that are long-lived that people just commit to and don't merge back into the mainline branch. It's difficult to determine what is the stable version of the code base. If people are not following a standardized process, this may lead to having a very difficult time to determine what changed when, and maybe how to revert processes to update that code base. That can be very painful and result in a lot of refactoring and technical debt. Another thing is, when we are building these new initiatives, a lot of times there's tight timelines on them, and we want to be able to move quickly and not have slow progress. We want to eliminate blockers as quickly as we can. And to achieve that and to avoid that, it's a journey. If you've worked on any sort of code-based build-outs or building applications, whether they're with a general purpose language or with infrastructure as code, you're probably familiar with the fact that this code base continues to evolve over time. There might be stable releases, but there's not a set in stone definition of done typically, other than what is required by the system requirement specification in order to design that software. But typically code bases evolve over time, new features are added, and especially when a team is leveraging a new set of process and tools, it takes time to get the muscle memory and the reps in. So think of it as a journey. And as you begin this journey, or you're already on this journey, you might encounter something like this, where you have a cloud deployment. And in this cloud deployment, this is an example case study that I'm just going to use as a way to demonstrate what type of processes and tools a team can use to accomplish something that is complex and complicated. So this deployment was all in AWS multi-availability zone setup. We have console, Vault, and Kubernetes being deployed in this environment. So the goal here was to leverage some functionality that Jake mentioned earlier, and that was leveraging console connect in order to control layer 7 traffic across a heterogeneous workload. So in this case, we have an auto-scaling group running Vault, and this is an older version of Vault at the time, but this is Vault Enterprise, and it required console as a backend. And then we have a standalone console cluster, and then we have a Kubernetes cluster, and we're using the managed service called EKS in Amazon. And in this case, we have Consul also deployed to the Kubernetes cluster, and we wanted to be able to control the traffic between the containers that were running inside of pods in Kubernetes, control the traffic between those applications and the Vault and Consul clusters that were running on VMs. So this deployment was fairly complicated. There was a lot of different config going on. We had VM-based workloads, we had Kubernetes-based workloads, and we also had some of the raw EC2 and cloud resources that we normally use in order to get our jobs done, like VPCs, subnets, load balancers, NAT gateways, and so on. So to start off, I'm going to take a step back. We talked a lot about tools, and we're talking about how we deploy things and what we're doing. However, software engineering and development typically follows a set of techniques that are tried and true. The domain has been around for decades now, and there's some very good methods and techniques that we could keep in the back of our heads when we're building software systems. One of them is that we want to be able to deploy things in a stable, consistent way. And we can do that with Terraform. Two, we want to be able to write efficient code and configurations that can be updated easily. And that is accomplished with having a branching strategy, having a merge request approval process, having that etiquette and discipline in order to get reviews on your code, having that release engineering process to create hot fixes if something goes wrong, or updating new features if you need to. It's very important to have that dialed in. And third, leveraging some development methodology. Agile is a very popular one. There might be others, but the ability to iterate quickly and safely and have the expectation of having stable code releasable every 2 weeks is something that a team starting this journey should hold close to their hearts, close to their minds, and hold each other accountable for this build out. Having these principles in mind when building code bases, when working together, when engineering something. So the first concept I'm going to talk about here is infrastructure as code and how Terraform plays its role in helping teams deploy resources into the cloud. Terraform is a tool that allows you to manage and provision resources. Jake mentioned some of this earlier. And one of the main things that personally I think is very advantageous for using Terraform is that it's cloud agnostic. It's a declarative language that allows you to define the desired state of the resources that you want, and Terraform will reconcile those differences, or will reconcile what you provided to reality. So it'll take the manifest and provision resources for you. And there's no specific order that you have to define. These implicit dependencies that you build into the configurations are resolved leveraging a directed acyclic graph internally. So Terraform is a cool tool that lets you basically not worry so much about the order in which things are provisioned, and just allows you to define, I want this provisioned, and Terraform will figure it out. Another thing that's very useful with infrastructure as code as general is that because it's code, because all the config is as code, all the resources are as code, we can leverage software development practices to manage and test all of the infrastructure as code we build. So we want to treat infrastructure as code, as a software development initiative. And a lot of times teams that are transitioning away from maybe more traditional ways of managing infrastructure are not very familiar with how or what they can do in terms of managing their source code with software development or engineering processes. So that's great that we can do that with infrastructure as code. We could build, test, and have a rhyme and reason for how we do things. Another very advantageous characteristic of Terraform is the fact that we have desired state management. We have the ability to have discrete deployments that exist. We could have potentially multiple environments that are leveraging the same modules or same Terraform code and be treated in a discrete way. Also, if we wanted to update an existing deployment, leveraging the concept of state, we can update manifests, and Terraform could look at the desired state and basically determine what the differences are and update the new features that you've added if it's possible. So this allows us to transparently change live systems very easily. So a lot of good things about using Terraform. Some of them are process oriented, some of them are focused on the functionality, and generally it plays nicely with a distributed team and people that are apt to software development. Okay, so I'm going to cover a couple of more characteristics that are great to know about if you haven't used Terraform, or to make a justification for using it. Dry runs. It's the ability to run a basically mock deployment of a manifest that you provide. You get to see what would happen if I did try to apply this configuration. That's great for not only continuous integration practices, but also for workstation testing. If I'm working with a team and I need to build, and I'm contributing, to a infrastructure's code base, then I need to see if I do add these changes, what would happen. And that can also be a feedback loop for the engineer that's building this to determine what do I need to do in order to make this work if it didn't, or it gives you the validation that, yes, these changes are going to function as I want them to. Another thing I mentioned earlier was change management. Terraform allows you to transparently update live infrastructure fairly easily with their CLI tool. So you can easily update infrastructure. You can create discrete environments with directory structures, and I'll share an example of that in a minute. But we have the ability to organize our code in a certain way that maps to potentially our organizational structure or our development team structure. Oftentimes it's an infrastructure team or operations team that's supporting a development effort. So having the ability to organize this stuff in a specific way based on your needs is very useful. Modules, if you're familiar with a programming language like Python, you get to import libraries or leverage the import command and leverage functionality that someone else has written or you have written yourself. And the advantage of leveraging something like a module or even comparatively a function is that we are able to abstract away complexity and create a very easy to use interface for our consumers or the individuals that are calling these modules, or in general purpose language terms, a function or some sort of library. So Terraform has the ability to create these modules. Modules allow us to reuse code. It gives us a consistent experience, and it lets us share things much more easily than having long imperative scripts or long scripts that we have to copy and paste over. We could just reference a module that exists, leveraging a relative path or with a Git URL. And another thing is that it's provider agnostic. You could even manage Kubernetes resources with Terraform. You could play with a lot of different clouds. If your organization is looking to have the multi-cloud strategy for that to be a reality, you can with Terraform. You could start with one cloud, get it down, get the process dialed in, and then from there, since HCL, which is the HashiCorp configuration language, is the language used to develop Terraform manifests, you're able to leverage the same language and point it to a different cloud. And as Jake mentioned, it's not a one-for-one mapping for resources. However, a lot of the resources in cloud platforms are similar. The syntax that you would use in the HCL would be a little bit different, but generally you would only have to learn one language, which is HCL in this case. So how would we manage if we had to support multiple dev teams? We have this new tool called Terraform. How do we actually create discrete environments? This is a very high level view of how we can do this. And so we have the top of the tree here is Terraform. And then we have inside of that at the same level, routes and docs. So I'm going to focus on the top half. Docs, which basically just documentation that's associated with the project. Documentation typically lives inside of the manifest themselves, if it makes sense. However, since Terraform is very straightforward to understand, it's self-documenting. So it's not like you have to put a ton of documentation in there, but sometimes it helps to provide runbooks or general gotchas or keep in minds for other developers or engineers that might be touching this code base down the line. So to break this down, there's this concept of a root, and a root is basically a directory in which we're running Terraform plan and applies from. As you can see, we have 3 roots here. This is just an arbitrary setup where we have dev, stage, and prod. You might have more, you might have less, but basically what we want to be able to do is have discrete environment with discrete state, referencing maybe similar modules. It's ideal to have production environments mirror development environments very closely, and that is also the case for staging and other subsequent environments if you need that. So if we leverage the same modules to provision infrastructure in the development environment, staging, and production, we have a much more streamlined, transparent way in which we're operating in these environments, since they all look very similar. And modules provide the ability to parameterize our deployments. So from dev, stage, and prod, there might be some differences, and we could program these differences in by leveraging variables that we can pass in during runtime. So we can actually create parameters that allow us to customize the deployments, but still use the same baseline modules. So modules, again, are very useful for reuse. And in this case, if we needed to support multiple environments that development teams are working in, we can do so and make all the environments look very similar to each other. So here's a very high level view of what it would look like if we had 3 discrete environments. So basically, there's a one-to-one mapping for directory structure, or sorry, directory here, development to an environment, stage to an environment, and prod to an environment. There's other methods and mechanisms that you can use in order to create isolation in your environment, one of which is called a Terraform Workspace in the open source Terraform tool. Terraform Workspaces allow you to have discrete state working in the same directory. So I'm not going to get too deep into detail, but Terraform Workspaces are a great way if you're working with a distributed team and they're all iterating on the development environment, for example, then you could have discrete environments for all team members. In order for them not to step on each other's toes. You can build environments without having to wait on another developer if they're working on it. And that increases general velocity if a team is trying to burn down tasks in the backlog and they're related to building out the development environment as the baseline for staging and prod. You can have multiple engineers working on that and not worry about stepping on each other's toes or upsetting anybody by accidentally destroying or applying anything, or basically getting it to a point where there's a state lock because someone's operating on that state. You don't have to worry about that with Terraform Workspaces. Another thing to point out in this diagram is that we have discrete state. So generally when we're leveraging Terraform and AWS, we use S3 as the object store to store the JSON file, which is the state. And in this case, we have potentially S3 buckets for individual environments, or we can just have paths within an S3 bucket in order to differentiate the state. I just wanted to explain that you can have discrete state for the environment so that there's a separation of concerns. So we have dev, stage, and prod. We don't have to have the worry about potentially modifying an attribute or characteristic in prod if we're working in dev. So for this team that's just starting off with their cloud initiative and they have to build this complex system, they understand now that Terraform provides the ability to deploy infrastructure as code in a stable, consistent way. With the same directory structure, with the ability to have discrete environments and state, teams can iterate on a Terraform code base at the same time and be very productive. So now that we have the tool and we know that it provides us the ability to instantiate resources, there's a lot of great characteristics and features of this tool that we could take advantage of. How do we actually manage the code base at scale? How do we manage this code base when we have a distributed team and maybe this code base exists for 1, 2, or 3 years? What can we do in order to make sure that regardless if there's engineers that move in and out to manage this code base or this project, what can we do to make sure that this code base evolves in a way that stays efficient, reduces technical debt, and helps teams deploy infrastructure faster? So naturally, when we're talking about source code management solutions, Git is a very popular version control system. You might be using something different. However, Git was made by Linus Torvalds in an attempt to make a more efficient version control system. And Git has the concept of a branch. And a branch is essentially a snapshot of a piece of, or a code base that allows you to determine the differences of what your branch is and what the mainline branch is. You can create dozens and dozens of branches, and it doesn't come with a lot of overhead. So having a bunch of branches is not a big deal. From an organization perspective, having branches be randomly made is not encouraged, but the fact is that branches are lightweight, and you can be assured that you could, create a branch and not create a lot of overhead. You work in your own silo in that little branch, not affecting the main line. And out of the use of branches, we can create release engineering processes. And specifically at Nebulaworks, we use a development methodology called trunk-based development. And here's a few characteristics of trunk-based development. It's a Git workflow where master is considered the trunk, and it's always stable and deployable. Trunk-based development encourages all of its team members to participate in pull request reviews and merge request reviews, depending on if you're in GitLab or GitHub. The nomenclature for merge request or pull request might differ. The idea is that when you're creating a proposal to get merged into the mainline, team members should always participate to make sure that there are no secrets being stored into the code, that all the code being committed is relevant, that if there's any efficiencies that can be achieved in it, that it could be addressed during that time. Another thing is trunk-based development and generally release engineering provides us to version our repo with release candidates and Git tags. So we have the ability to basically have point-in-time versions of the repository where we know it's been tested and it's stable, which is very advantageous for teams that are trying to get consistency in their deployments. They have a sane way to test and build and merge their code. So when we do get to the end of a release and we do cut a tag, we know that that version of that code base is vetted out and works well. So an example of a trunk-based flow is first you start with a new branch. This assumes that the developer has cloned down the repo, did a git pull, rebase, master in order to get the latest latest changes for the master, and then they create a new branch. And typically this branch is associated with an issue inside of a Git repository. In our internal R process is to leverage the issue tracking boards within the source code management solution. So we use GitLab internally. So this tool GitLab has the ability to create different types of boards, and we prefer Kanban boards. And Kanban is Japanese for visual signal. So that allows a development team to visualize the burn down of these tasks. We can move them from left to right in a column, and we have the ability to have a lot of transparency in what's going on. So trunk-based flow generally starts like this. You branch, you iterate on it, you grab your cup of coffee, you grind out some code, your hands on the keyboard, you add new features, stability or fixes, and you test. You test locally on your workstation with the plan. Depending on what continuous integration exists for your team, that's when you can have these automated tests trigger. So initially, when you first create the branch, you will have to push up the new branch to your source code management solution. After that, you have the ability to push commits up. Another thing to mention is that commits should be atomic and meaningful. Commits are very important because if we needed to basically cherry pick a commit or drop a commit completely, it should be self-contained. It should be logically associated changes so that we can basically modify commit history if we can. So it's not like we have a bunch of commits, like 30 commits for a merge request that are just like update, 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 which we have seen before. But leveraging the rebase functionality in Git to squash commits when relevant is something that we always promote internally. So once we have all the changes we want, we've tested it, we can create a pull request. And this pull request or merge request essentially puts your proposal on blast for everybody to look at. So you can get reviews. You can make sure that the code that you're committing is it's good code, it's stable, and it addresses all the issues that were identified inside of that, the issue that was created in the Kanban board. So once the pull request goes through, then we can actually merge this into the master branch. And once that's merged in, we can rinse and repeat this process and take another issue from the Kanban board, branch, and so on. So this process probably seems very common if you have built code bases, if you've been working on a software development team. Trunk-based is the way we use the branches. You might be using Git flow or GitHub flow or a different type of methodology. However, it's important to just have a process in place. Doesn't really matter what it is, whatever suits your needs, but having a process and having people be accountable in terms of following that process is extremely important. Now, what can we do to actually test our Terraform infrastructure? There's one open source method that I'll share briefly here, and it leverages a tool called Atlantis. So Terraform, a Terraform merge request is made. So we modified some Terraform. We want to merge it into the main line. As soon as we create this merge request, Atlantis, which is a server that we have running in Kubernetes, runs an automatic Terraform plan. And it provides feedback to the merge request user interface to let us know if this thing planned like we wanted it to. Is the behavior that we anticipated there? Typically, continuous integration is a bot that's doing it's validating human actions. So for the CI component of this, we're just basically doing the same set of tests that we would on our local workstation. So at this point, if the Terraform plan looks good, if all the configs in the proposed merge request look good, then the team members review the whole change proposal and approve the merge request. Once it's approved, and only when it's approved, you can leverage a chatbot-based pattern where you can comment to the merge request and type in Atlantis apply, which will run Terraform apply and apply the changes that you have proposed in this merge request to reality. So you now have your changes, they were planned, there was a approval for that specific merge request and commits, and now it's ready to be applied to an environment, whether it's development, staging, or production. And once those changes are applied and they worked, sometimes once in a while it doesn't, and you have to kind of start over again, update the merge request, plan, apply, and then it has the ability to merge. So when working with a distributed team, all using Terraform or even other tooling, it's important that the workstations their own workstations should mirror production environments as closely as possible, or they have access to environments that mirror production as closely as possible. With infrastructure, it's not very common to have all that infrastructure on the local workstation. And in this case, it would make sense if you're leveraging containers or building Kubernetes applications. You could have a Kubernetes cluster or container runtime on your local workstation. And that would guarantee that if you could run it on your laptop with the correct versions of the container runtime and the container CLI tool, that it would work in production. Another thing is to version pin all binaries. We've gotten bit before where we've been subject to what we call drive-by applies. And this happens when a team member updates their Terraform version to a latest version, and everybody else is not doing that. They version pinned. We've tested all the infrastructure that we built with this specific version. Somebody updates it with no rhyme or reason, their binary, and they run and apply. And so now Terraform is only capable of working with that latest version, requiring everybody to actually upgrade their binaries as well. And this creates a lot of just confusion. Sometimes it's like, what's going on? My Terraform plan and applies is not working anymore. And it's because maybe someone updated their binaries, causing headaches, causing burn cycles, and potentially even injecting regression errors. If we upgrade to a new version of anything, we have to make sure that we actually test the code that we already have with this newer version to make sure that it didn't break or introduce any breaking changes. Another thing I mentioned earlier was enforcing that standardized branching and release engineering process. So one of the biggest pitfalls that I've encountered when working with a variety of different teams working as a senior cloud engineer is the fact that a lot of times organizations are not enforcing standardized release engineering process or branching strategies. So you have maybe a very long-lived branches, or all team members have their own branch, and it's just a mess to try to merge things in or determine what's the stable version of the repo, what branch is stable. So having a standard around that exactly, where's the stable code, how do we make changes to this code base, and how do we merge all these new changes back into the mainline branch in a sane and efficient way. Another thing is to give the freedom to your developers or engineers, in this case, infrastructure engineers, the ability to test out their infrastructure as code in development environments. So promoting self-sufficiency, giving the engineers the tools they need to be creative, to be efficient, and be self-sufficient, most importantly. So with a tool like Terraform, great, amazing tool for deploying infrastructure. Now we have a branching strategy and release engineering process that we're going to follow and hold each other accountable to. Now we have a way to organize all this infrastructure as code. We know that this process can last years even if we stick to it. So we have a standard way to iterate on a code base. So now, how do we actually make a complex system a reality? So this next section is on generally our approach to agile development. So this process is, if you're familiar with software engineering methodologies or software development methodologies, or even things like Agile, Scrum, this might look very familiar. So at a high level, we identify a problem to solve, the team that's going to solve it, the tools we're going to use, and the timeline. At this point, we all put our heads together, determine a formal specification and requirements of the system to build. And then once we understand this, we have the kickoff meeting. This kickoff meeting is focused on generating a backlog of issues in order to accomplish the goal of this system that we're building. So we point these issues with a Fibonacci sequence in order to associate a complexity to the issue, and generally use divide and conquer, the divide and conquer process in order to build these complex systems. We take a big problem, potentially even an abstract problem, and we figure out what's the easiest and simplest way to start to break this down into consumable issues that engineers can go and build. Another thing is to have whether it's a Kanban board or some other board, to visualize what issues exist, to create transparency for stakeholders, for leadership, for managers, to see what is being done. Oftentimes, developers or engineers that are not leveraging these issues do not contribute their code or their files back into the source code, resulting in silos or having to ask someone, where's the code for this config? If you have like a network config, why is it not in the repository? Holding people accountable by basically assigning issues to them, letting them understand what they need to do, and letting them show progress is very important. And of course, having releases at the end of every sprint allow us to release, regroup, and reorganize. Oftentimes, sometimes issues fall through the backlog into the next sprint. So we have to figure out, is this the same amount of points that we anticipated? Is it more difficult? Is it easier? What other things do the engineers determine we needed to accomplish in this next sprint? A lot of times things come up where you don't know what you don't know, and you have to figure out new solutions or workarounds as you build or engineer things. And at the end of the timeline, you have your system deployed, and you can now look at this new system with a fresh set of eyes starting at step one and figure out what new functionality, what new features can I add to this system to make it more, adding more value for the consumers of it or the internal customers, whether it's a development team or potentially another infrastructure team. This is a diagram that was built for this project specifically, the deployment of Console Vault Kubernetes inside of the cloud. And as you can see, this is a very high level diagram, and it really serves to be a point of reference for driving projects. So at the top, we have the sprints, the weeks, and categories, and then the deliverables. So as you notice, the top, there's a arrow going in both directions, and it says research, testing, documentation. So this is continuous. We're constantly figuring out if there's anything new that we need to understand. Sometimes versions of this software drop so quickly. I remember with Console and with Terraform, as we're leveraging these, for an extended period of time, we have to keep up with all the updates to them because the updates happen so often. So we have to make sure that we understand what's coming up. We understand what new features allow us to do and what they don't allow us to do. So coming down to the category section, generally cloud deployments, in my experience, go something like this. First, we have a phase or a sprint or maybe two sprints of raw infrastructure scaffolding. So this is where we leverage Terraform to build the VPCs, the subnets, the Bastion hosts, the NAT gateways, all the things that we need in order to support infrastructure to live in that environment. So we're putting up the guardrails, we're building out the frame or scaffolding up the things that we need in order to make this thing a reality. Then we can start building the auto-scaling groups, the EKS clusters themselves, and start prepping these EC2 instances to start being configured with the appropriate service configs for Vault, for Console, and so on. Once we have that raw infrastructure up, we could then start really configuring and tying all this stuff together. So the second sprint, which is the most dense here, was basically taking things like Helm and deploying the Console Helm chart, metric server, Elasticsearch, making sure Console Connect was working with Envoy, testing the connectivity between Vault and the Kubernetes cluster, syncing the Kubernetes catalog with the Console service catalog for service discovery. So this was the meat of what was happening. And this was really just dialing in on the configuration needed to meet the system and the system requirements and specifications. And then finally, we have validation and documentation. We use ServerSpec in order to validate server config. So ServerSpec is a tool that lets you point basically this application or this this framework at instances, EC2 instances in AWS, for example, and allows you to search certain directory paths to determine if things are there, or if you could, if you had a valid config, you could check that EC2 instance to determine if that EC2 instance has a valid config, and so on. So it's really for a regression test. You can run these tests in a continuous integration job, you know, just to have that extra assurance that your servers that you're provisioning are behaving the way that you want them to. And then again, developing the runbooks, end-to-end testing, going from scratch, deploying this system to basically from start, Terraform apply, to finish provisioning, testing all of the functionality that we built out in Console, with Console Connect, with Vault, inside of Kubernetes. So at the end, we have this assurance that repeatedly we can build this thing consistently. Sometimes there's like timeout errors or issues with timing that come up when you're deploying distributed systems, and sometimes they're one-off cases or edge cases. So doing this repeated testing end to end is good to catch those. And why should we use you know, Agile or all this process that I'm talking about? Well, in general, it helps us create and deploy stable versions of infrastructure that we build. If you think about it, we have these requests coming in from development teams or internal customers on this constant flow. So we're always getting in these new requirements. How do we make sure that the process that we're using is something that's well understood and somewhat static? Well, it's actually putting these processes into place. It's putting the Agile framework into place and having everybody follow them. Leveraging release engineering processes to make changes to environments based on business demand. We want to make release engineering and hot fixes and you know, merges of branches non-events. They shouldn't be these large ceremonial things. It should be something that happens very frequently and that all team members are well versed in. Another thing is the ability to transparently change and test new features to the system. Having a framework like Agile allows you to inject new issues into the backlog. It gives the team flexibility in order to reorganize and reprioritize issues and features, and generally encourages incremental development. If we have issues that are consumable for engineers, they could be committing and pushing and merging code every day, every 2 days, depending on the complexity. However, if you're using this framework, you're giving the runway, you're giving you're equipping your engineers to be able to commit frequently, get wins more quickly. It feels great to get a merge request merged or pull request merged. And it allows us to release code frequently because we're incrementally adding new features frequently. So it all kind of ties together, from releases to how our branching strategy allows us to accommodate new changes to the code base. So Agile allows us to iterate quickly and safely with a plan, with a well understood strategy. We have what we need. We have the roadmap in order to make that complex distributed system a reality. So now, coming towards the end of this presentation, I'm going to just summarize very quickly what we talked about today. So infrastructure as code and Terraform allow us to deploy infrastructure in a stable, consistent way. Trunk-based development, or some sort of development methodology or branching strategy, allows us to make updates to the code bases easily. It allows us to get pull request reviews in order to make our code more efficient. And finally, we have the Agile Framework, which gives our team the ability to iterate quickly and safely, have flexibility to make changes based on internal customer requirements or workarounds, things like that, and have stable code releasable every 2 weeks. So that concludes my presentation here. And before I hand it over to Anne, I'd just like to say thank you, everybody, for attending. Thank you, Jake, for presenting today. And if you want to reach out to us, we have a few avenues to do so. We have the Cloud Natives community, which is a community-driven meetup group that talks about DevOps, talks about cloud, automation, things like that, things like we talked about today. So if you're curious about these types of topics, check out the Cloud Natives meetups. We have a YouTube channel. I know HashiCorp as well has a YouTube channel. There's great content there. And we also have a DevOps Wire newsletter where we send our community a collection of different articles and insights, literature that we think would be useful for them to know. So Anne, I'll hand it back to you.
Perfect. Thank you so much for a great presentation, Jake and Anthony. So it's time for some questions. The first question is for Jake. How often in the field do you see customers using the whole HashiCorp stack with Terraform, Vault, Console, and Nomad versus only one or two?
I mean, it really depends on where a customer is in their journey, and sometimes just what their needs are, right? So we say this all the time, and you hear Armand, one of our founders, say, workflow is not technology quite a bit. Mitchell will say it as well. And the concept really is that our tools are just kind of fit into any workflow that you have. And so if you're sort of brand new to cloud-based discipline and you're looking for a holistic solution, then a full stack may be a great choice for you. But if you already have, pieces of these, in place already, very likely most folks are going to, adopt it at different rates. And so the vast majority of our early customer adoption through our tool sets is probably going to start off with Terraform and or Vault, right? So folks usually have a need for really, deep secrets management, or they just have this infrastructure deployment need. And then, really Console and Nomad are relatively advanced concepts still, I think, with it, within most application frameworks. A lot of folks are still using, direct VMs or direct machines for this. And so it's just kind of a journey. And so, some of the examples like Roblox, for instance, they implement a full stack. We see some other ones. I don't know if I can reference these or not. So I have a lot of customers in mind, and I just want to check myself to make sure that I don't say something I shouldn't in a live situation. But yeah, I think what we also find is that folks who are maybe like born in the cloud style, maybe they choose Kubernetes over Nomad, but they want to integrate some of their non-Kubernetes environments. And so you'll see Console, Vault, and Terraform used for sure. So again, it varies. Like I don't have an actual customer count, but like I said, I think the vast majority of folks are probably very heavy on Terraform and Vault, and then some of the more advanced customers will use the full stack. We are seeing a lot more traction on Nomad for sure. So again, you see some of this stuff with like Roblox and Cloudflare and some other folks that are really starting to adopt it. And with that, we're starting to see more people who are very that only really think about Kubernetes as a scheduling option now starting to consider that, and so that.
Thank you, Jake, for a very elaborate answer. This one's for you, Anthony. I love the idea of enabling teams and giving them powerful tools to leverage. How do you usually tackle the challenge of adopting these tools and enforcing the discipline of code etiquette you were mentioning?
Yeah, that is, I think, the biggest challenge for teams that are, leveraging a new tool or new process, or maybe they are not familiar with this new paradigm of infrastructure as code, or working as a software developer. So I think the main thing to determine is maybe educating people that are not really familiar with the branching strategy or code etiquette because they haven't seen it before, or they haven't really worked with a big team. Giving them or equipping them with the knowledge in order to be successful is important. Another thing is just personal accountability and discipline. If you're working with a team that is following that process, you have to stick to it. And encouraging people to push frequently, get reviews on their merge requests. I think that builds rapport within an engineering team and generally makes it easier to follow and enforce those standards.
Perfect. Thank you, Anthony. So another question for you. If my team is currently experiencing the pitfalls that you mentioned today, what are some first steps we need to consider taking?
Yeah, so I think that one's for me, right? Or
yep, for you.
Okay. I think sometimes looking at a code base can really identify the skeletons in the closet. I think looking at how the life of a branch, or how changes are being moved to master, and how teams are actually building something is important. To kind of do some reflection, look at what processes we're currently leveraging, and are they helping us achieve what we want to? Because the tools might change over time. However, if you don't have the process dialed in, and it might in a year that engineer that was building that code base leaves, then who knows if the next person is going to be able to pick it up. So having standardization is really important for an engineering team. So I think looking at that, having someone that's experienced come in and maybe provide suggestions on how to improve that process would also be a good option.
Perfect. And then this one is for Anthony and Jake. When would I use Terraform versus Ansible? Jake, we'll have you answer first.
Yeah, it's great. I mean, I come from a Puppet world, but yeah, you use them both really. There's each of those tools has sort of a different set of scope. Terraform is very, very aimed at doing infrastructure provisioning, whereas Ansible is more sort of the last mile configurations. A couple patterns that I actually see people use quite a bit is one of two things. I see them use a combination of Ansible and Packer to create immutable images if you're into immutable infrastructure patterns. If you are or not, the other pattern I see is launch Terraform to create your infrastructure parts, and then use Terraform to do the config. Or I mean, sorry, did I do that backwards? Use Terraform to do provision infrastructure, and then use Ansible to actually configure sort of last mile configuration. So either of those works. You can actually use it. You can sandwich Terraform with Ansible as well. So do immutable infrastructure for the most part. And if you have last mile configurations that you have to do, maybe you just run those after you do your Terraform infrastructure. But yeah, absolutely, I've seen use them both. And of course, so you can kind of insert configuration management. So if you're using Chef or Puppet, or whatever homegrown scripts or something like that, heaven forbid CF Engine, you could use that same kind of sandwiching method.
All right, Anthony.
Yeah, I agree. I mean, I think everything that Jake said is valid. I mean, yeah, I think the leveraging immutable strategy, baking in the configuration management dependencies into a base image, and then having that, config management tool able to run to do that last mile config. Another method that you could use is leveraging, if you're using specifically AWS and EC2, is leverage CloudInit and user data in order to install the, whether it's the Ansible runtime or Chef or whatever you're using, Puppet, install it there, and then, maybe clone down a specific type of repo that has the runbooks or the configs that you need to apply, and apply it through there. So I've seen that very often, leveraging user data or CloudInit to bootstrap config management tools inside of the cloud. If you have a library of Puppet manifest, for example, and you want to get some reuse out of it, you could basically just leverage Terraform to bootstrap infrastructure, as Jake said, and then in the CloudInit user data component of that EC2 instance, have Puppet installed and maybe pull down a repo with the specific library that you wanted to use to configure things. So, they could be used in tandem for sure.
Perfect. Thank you, Jake and Anthony. And then this last question is for both of you as well. What are some challenges, the biggest challenges teams face when using a tool like Terraform? We'll have you answer first, Anthony.
Yeah, I think scalability is one thing. I think governance is another thing. I think it's pretty simple to just run a Terraform manifest and provision resources in the cloud. But how would an organization do it if they have a team of 24 individuals, or they have a bunch of developers or infrastructure engineers that are provisioning things manually? Basically breaking those bad habits and having people follow the more consolidated approach towards infrastructure management and making sure everything is codified, I think is a challenge. And there's certain tools that allow you to do that. I'm sure I'll hand it over to Jake. I think yeah, that's my answer.
Yeah, so oddly enough, the reason that I work at HashiCorp is because of a discussion that I was having at reInvent with Brian Green, who now sort of runs part of the professional services division for us. But he ended up being my hiring manager, and the reason I went to talk to the folks there is because code sort of structure was something that just wasn't very well talked about in those days. There were only a couple of folks who were pretty loud about it. The folks at Gruntworks, certainly one of them, and there was another lady, I think her name was Chastity, who had blog posts, and they were literally like the only two sort of opinions about how to do code organization. And so one of the sort of interesting things about, say, Terraform Cloud, even the free version of it, is that the workspaces help you organize your code a heck of a lot better and do code reuse. use. And so that's a major thing we see with our customers when they come to us for enterprise problems as well, is that they just have these really large sort of monolithic repos that have lots of different folder structures for different environments. And it's hard to manage, because then when you update code in one, you're either going to copy it into another folder, or you come up with these kind of weird workspace management techniques in order to do that. And so that's of utmost importance. And then secondly, Anthony mentioned governance, and this is a huge thing as well, is like, how do I enforce sort of a set of rules that people have when say when I release things into the wild, make sure they don't use like these really large instances for development environments, or make sure that you don't violate 0.0.0.0 opening up your networks to to outside influences for any of your VPCs or any of your environments like that. And so Sentinel, it's clearly it's an enterprise feature, but that's a lot of times what sort of drives people at least initially towards the enterprise versions of the software, is because then you can add a layer of sort of protection on top of these things. And so those are some of the major things that we see from our customers. And then again, just the scalability. Like now I have hundreds of people who are using Terraform, and if they're using it locally, that's an absolute mess, because we don't know where those state files end up. Maybe they're in an S3 Dynamo pattern, and then managing those things can get a little bit out of hand. So again, Anthony touched on it there. I just want to give some specific examples of things I've seen that this is why our enterprise level of software is there, is to address like these issues of scales and governance. And then sort of the code organization, you get that for free with Terraform Cloud if you get a free account as well.
Perfect. Thanks, Jake and Anthony. Before we wrap it up, was there anything else either of you like to add?
Yeah, so I mean, just a bit of trivia. So just after I started working here just before our sales kicked off a little over 2 years ago. And the very first partner that I met was Nebulaworks. You folks ran a little event for us at a bowling alley up in San Francisco. And so it's, and you're close by as well, because I'm in LA and you guys are in Orange County. And so, it's been great working with you guys. I really like the work you guys have been doing and helping our customers. So a big thanks for all the work that y'all do, and for inviting me to speak at this. So thanks for that.
Jay, we feel the same way.
Thank you, Jay.
All right, anything from you, Anthony?
No, I just wanted to thank everybody for not much, just thank you, everybody. Hope everybody's healthy and staying positive. But other than that, thanks, Jake and Ann, for helping putting this together.
Perfect. And then if people have more questions, how can they reach out to the both of you?
LinkedIn, Twitter, my email is anthony@nebulaworks.com. I'm open to all those different avenues.
Perfect.
Yeah, and you can reach me at Lundberg at HashiCorp.com. Also, Jake Lundberg on Twitter. And if you write Aquaman, I may respond to it, but we'll see. It's up in the air these days. So yeah, those are the best avenues.
Perfect. Thank you so much, Jake and Anthony, for a great presentation. And thank you so much, everyone, for joining us today. Hopefully you learned a little bit more about the HashiCorp stack, as well as some best practices around software engineering principles. We will be following up with a video recording from this session, and along with additional content. Thanks again for joining us, and I hope you have a great rest of your week. Take care. Bye.
Thanks, everybody.
Thanks.